We're going to get started in a minute. Hey, good evening, everybody. My name is Balaji Siva. I'm the organizer of the South Bay Spinnaker Meetups. This is actually our 5th meetup. Mostly we have it in Netflix. We had one at Cisco, and today, thanks to Pure Storage, we have it in Mountain View due to popular demand. Nobody wants to go down to Las Gatos or so this is actually in a much better spot for most people. So today we have a great sessions. I think most of the sessions, I think Pure Storage is going to talk about their Spinnaker usage, their lessons learned. We have a couple of lightning talks at the end, which is actually one of them is from Opsimax on how to enable Spinnaker in a secure container environment with security constraints. And there's another talk by Pure Storage on auditing project that they're working on inside Pure Storage. We always look for speakers. Today, if you have a lightning topic that you want to talk about, on any topic you want to talk about, feel free to, maybe we can have a impromptu lightning talk if you want at the end. We always look for speakers as well as sponsors, like sponsors as in venue sponsors. If you are interested in speaking, let me know. My name is Balaji, and you can find me, I guess, at the end. So with that, with much further ado, let's go to Tony.
All right.
Tony's show today.
All right. Thanks.
Well, hi, my name is Tony Drain. I am the Site Reliability Engineering Manager for Pure Storage. Thank you guys so much for taking time out of your busy schedules to come here tonight. We really appreciate it. We put together a program for you that hopefully you'll find beneficial and informational. So let's see a show of hands of how many people are new to Spinnaker. Cool. How many of you guys are here just for the free beer? Yeah, that's what I thought. So we'll be having a little social at St. Stephen's Green, just down the street on Castro Street after this talk is over with tonight. So I want to take a little bit of time to talk about Pure Storage, our reliability story, and how we've come to use and embrace Spinnaker here. Pure was founded in 2009 with a mission of how to enable people to build better products. And with that, we defied kind of industry conventions by making products that are super easy and intuitive to use. And because of this, Pure just did $1 billion in terms of revenue last year. We're one of the fastest companies in this space to reach $1 billion mark. So that's something that we're certainly proud of here. We've been recognized by Gartner as a leader in solid state arrays for the past 4 years. And we've also been recognized by Glassdoor and Fortune magazine as one of the best places to work in the Valley. So this is a pretty exciting time to be here as an engineer. And so going back to just hitting upon simplicity just for a minute, that's where Pure's Cloud comes into play. Our cloud is central to our simplicity story here at Pure. Our services are used by our customers to manage storage on their array, manage the performance on their array. The cloud also offers tools to do workload analysis, as well as VM management. It also plays a central role to our technical support story as well. Our data analytics engines can predict hardware and performance issues with our arrays and data centers before our customers even know about it. And this is where my team comes in. My development team is responsibility of the reliability of the business critical infrastructure at Pure Storage. We own the infrastructure here, and we also partner with cloud teams to host their applications on infrastructure that we manage at Pure. So we deliver a variety of different services. We do production readiness reviews. We do monitoring. We work with teams on their monitoring strategies, upstream and downstream dependencies. We are obsessed with automation. And finally, we participate in all cloud postmortems. And that's how we, that's the key that we drive our work to here, making sure that we learn from our outages and making sure that we harden our services to deliver robust infrastructure. So what does all this have to do with Spinnaker? Well, Ben Turk on my team in a few minutes, he's going to come up and he's going to do a deep dive into Spinnaker at Pure. But at a high level, the ability to do repeatable, reliable, fast deployments has been huge to our reliability story here at Pure. When I first came aboard here, we had a ton of postmortems, a ton of outages due to configuration management issues. After the cloud teams here adopted Spinnaker, we drove those outages down to zero. And because of this success story, Pure has been actively involved in the Spinnaker community. We've done everything from contributing to the open source project to writing internal tools that call the Spinnaker API so we can manage our servers and services. So before I bring Ben up, I want to just do a couple blocking, tackling things. Please save your questions to the end of each session. That will allow the presenters to get through their presentations. We have these little cube things, microphones built into them. We can toss them around. So if you speak into them, folks will be able to hear your questions on the video that we're recording. And finally, we've got volunteers manning that door back there to escort you guys to the bathroom or in and out of the building because security doesn't want you guys walking around all willy-nilly. So if you could respect that, we'd appreciate it. So with that, I want to introduce you guys to Ben Turk. Ben Turk is a senior SRE on my team. This is the guy that really drove the adoption of Spinnaker here. He's been an evangelist for the product since day one. So I can't think of a better person to kick this event off. So without further ado, Ben Turk.
Thank you, Tony, for your kind words there. Also, as I get started, thank you to Netflix, Google, and anyone else who's contributed code to this tool, as it has done a lot of good things, as Tony mentioned just now. I've been to a few of these meetups, and I've noticed, like when Tony did the show of hands, there has been a significant percentage of the room of people that haven't used Spinnaker before. So the talk I'm going to do now is really just showing the journey that we've had rather than a technical one, and what benefits we've had out of it and that type of thing. So yeah, my name is Ben Turk, and I have a lot of people come and ask me where you're from and what part of Australia, and I thought the easiest way is just to quickly throw up a map and answer that question once in my presentation. So I'm originally from Adelaide in South Australia, where the little red dot is there, and I spent about 7 years in Brisbane in Queensland, where the red dot is now. Yeah, and I'm a site reliability here. The first hurdle that we had when I identified that Spinnaker was going to be a good fit for us was engineering buy-in, and that's really not to be underestimated by any means. When people have the way that they're doing things, the tools that they're comfortable with, the tools they've used in previous jobs, sometimes it's a hard sell to get people to change. So a lot of it was going around and looking at all the common pain points, and collating that information, and then looking at what Spinnaker itself would solve there, and then addressing those pain points one by one, and then demonstrating it. So the next step was to build the tool, get it working, and then start demonstrating the pain point. But the SRE approach of how we rolled that out was really key, in that before we released it to our engineers, we made sure that we had Spinnaker, building Spinnaker with itself, we had it as an immutable image with its configuration built in for us, so it would self-heal, so that people wouldn't be blocked by the new tool. There was a lot of consideration that we took in, and to credit to the authors of Spinnaker tool itself, it really just fit right into that and ran smoothly, and we really, the self-healing didn't really need to happen because it was pretty stable. And we went into production around 420 in 17 with it. Our initial journey was package based, so we took all the configuration and we built a Debian package, and then we installed the Spinnaker packages and had our package come down last with the configuration on top. Halyard now is the recommended way to do that. We currently have an effort to migrate to that, and Dan's going to talk a little bit about that after me. That's how we initially started. Again, we have Spinnaker building our Spinnaker for our first engineering teams. We also have roll forward, roll back capabilities that we've been using, and that was one of the pain points that we looked at. So when you have configuration tools like Chef, Puppet, Salt, Ansible, you apply changes directly to production, and you on a bit of a one-way ticket. And then when your change is done, then the rollback is a little bit more difficult. So we used Spinnaker to roll out these immutable images, and that was one big pain point. And that's something for people that aren't using Spinnaker, I would strongly suggest you look at using Spinnaker that way. You could, by all means, push out an image and then run Chef and Ansible or Puppet or anything on top of the image that you deploy, but it's not going to give you that self-healing, reliable story. We've onboarded more than 50% of Pure's cloud services to using Spinnaker. The number's probably more like 75, 80%. And things are much, much better with Spinnaker for us. Like, it's been a huge change for us. Stability, as Tony mentioned, we had a lot of postmortems due to those changes, directly modifying production with that DevOps model of just going in and just doing it live, adjusting production. This immutable way of deploying, we used the AWS deployment model, it's just taken that away, and we don't have those issues, and our engineering throughput's increased because we're not dealing with those problems. The self-healing became front and center our design. It's really encouraged us to use the Amazon features to do so. Like, it's just so intuitive. Like, if you start clicking around and start setting up those pipelines, it encourages you to do the right thing. You know, it shows you the load balancer health checks. It shows you all those things that you should be using. They're there. And it really walks you down the right path. So to the authors, again, like, that was a really, good design to put all those hidden features that you don't generally see in the Amazon console or the Amazon CLI. It just puts it all in a really usable way. Deliver what you need to deliver. We've built a lot of in-house tools to enhance monitoring and stability. We built an in-house tool called Erical, and that ties in with the self-healing. So we've report back through our health checks through the load balancer, like if the server's healthy, and if it's not, because now it's immutable, it gets terminated and replaced. The roll forward and roll back's been great when needed, but we've really needed to use it. It's the stability increase that we got just by using all these features that were front and center for us has meant that I think we've used it 3 times since we went to production, as far as I'm aware. Now, talk a little bit about release, and this comes to good design, intelligent design as well. It's encouraged us to strive for continuous delivery rather than just CI. and there's a big gap between CI and CD, as everyone's in this room is probably aware. The testing that you need to have in place, the tools, there's the new Canary feature that's recently been released. We have not using it yet, but the things like that to get you to CD is just something that we've been striving for. We do have a percentage of our pipelines that do CD. We want to increase that. For those people that are setting up for the first time, I really encourage you to use the manual judgment step though, as you get started, before you don't go straight CD straight away. We're really looking forward to Canary, and being able to report in applications based on a base AMI patch level it's been really huge. So we use there's a way to adjust your tags. So any instance that we fire up, we give a base AMI as a tag for it that it was derived from. So from a security report perspective with the API tool, which Sergey will talk about later, we can derive a report of our patch level in production without having to touch a server. So for compliance people, they'll get excited about that sort of thing. The other thing to talk about is when you have your immutable servers, like I'm talking about, deployed with a tool like Spinnaker, there's no need to touch them once they start in production because the image snapshot contains everything that it needs. So now you're not reliant on a Puppet server, a Salt server, some configuration bucket of something to bring your server up to a working state when it starts. So those errors that you get from automatic startup with automatic tools to configure it, they go away because you've already got a pre-tested image with everything it needs. And yeah, it's just designed to get us, help us get the most out of it. So it's been a really good production journey for us, as Tony mentioned. Engineering throughput, this one always gets managers excited. Having a common tool has really helped engineering. So for all the teams that have picked it up, it's meant that engineers from Team A and Team B are familiar with the tool and the methodology of getting software into production. So it's meant that when collaboration time is required, the engineers aren't spending time figuring out, oh, well, you've got these Jenkins jobs that do this and I need to figure out what's going on first. I'm not really trying to pick on Jenkins here. It could be scripts, it could be anything. But if everything's different, then the engineer has to figure out the different way of doing things before they can help the other engineer. So having that common way has helped. Also, moving between teams is a lot easier for these engineers because they don't have to learn the other way, the other teams deploying things or the custom things first. They just sort of can drop in there and start writing software and contributing to the pipeline. The velocity seems to have increased from what I can see. The deployment quality is definitely increased. So we don't have those issues in production. We got lights out. And all our deployments are going through the pipeline. So this is another intelligent design. It really makes you think about things. So we're using the pipeline. So every change we make goes through to dev, through stage, through prod. So again, we're not directly manipulating production. So we're not directly breaking production without testing that change elsewhere. And we're also not having something break in the process of doing the change to production that worked everywhere else. And I'm sure we've all been there. Finish line, this was here to remind me to say that this tool, Spinnaker itself, is something that I'm seeing evolving, and stuff is continually being applied to it, and there's Kubernetes work that's going on with it, and there's just so many new things coming into it that the finish line is always almost there, but not quite, because there's this new cool thing that you can use on it, and this is something that should be celebrated. So I would definitely plan for continually looking and keeping in sync with the open source community, looking at the Kubernetes sync up groups and things like that, looking at the new tools like Canary, and then investing into using those new cool tools and features, and don't sit still on it. I do want to call up Hubert, which is one of our engineers from one of our teams, to talk about what Spinnaker's how it's changed his experience in his team here at Pure, so you could hear from one of the engineers of how this has impacted them. And that's really the end of my talk.
Hello, everyone. I'm Hubert Chan. I'm part of the Pure One team. I think Spinnaker has made a pretty significant impact to our team. I think especially for those teams who work across both FlashArray, which is our core product, and also the cloud. Because like for someone like my team, we don't look at Amazon every day, right? So we kind of treat it like a black box. Like I remember like a year ago, when we were still using SaltStack, which is the software that we use for Spinnaker, we would have to configure YAML files for the Salt, and then we would have to go to Amazon console to configure a security group, provision EC2 instances, create ELB. And the experience is very destroying that it's very hard to understand what I need to do in order to create and deploy a service to the cloud. And so in the end, we treat it like a black box, and it's obviously is a pain point for us. And whenever we need to do something, we'll have to file interrupts to SRE. And when everyone is doing that, SRE is overwhelmed and everything slows down. Right? So, but Spinnaker changed that because I like it because everything is in the same view. So immediately I know that if I need to deploy a service, I need to do all these. I need to do a security group here. I need to do create a load balancer. I know how to create a service pipeline. And the experience is very smooth and it's very easy to learn. And everyone on my team got quickly ramp up. And in the end, we were able to like onboard all our services to Spinnaker in less than a quarter, right? Like less than 3 months. And when everyone is having similar knowledge with Spinnaker, it's very easy to make changes. And we no longer funnel everything through 1 or 2 individuals or funnel everything through SREs. So we are able to react to problems faster, right? And I think that's the first benefit to our team. And another benefit is is the velocity, like Ben just mentioned. Before Spinnaker, when we were still using Salt, we had a single release branch. And every time we push code to release branch, all the services in production will be updated. And this is pretty troubling because we could be pushing to one service, but in the process, we could be updating other services as well. And in the process, we could break other things. So in the end, we tried not to push as often, and we tend to wait until the very end before we push stuff to production. And that basically is slowed down, and we are not bringing the most value to our end users. And again, Spinnaker help us because we can now create like independent deployment pipeline, and we have finer grained control over what we want to land in production without affecting all our other services. And so we kind of changed it from like pushing probably once a month to pushing at least once per week. And we can even do like twice a week as well. So that's pretty good. And I think the last benefit to our team is it's enforcing and also standardizing the deployment process because again, pre-Spinnaker dates, we would be installing our Debian package to an EC2 instance, and we could always risk someone making some local changes in the production instance to make some quick fixes, and the risk is people will forget to bring it back to the code, and that means next time when we push code, it's a regression, right? So Spinnaker saved us because I do like the model of promoting your immutable image across different environments from dev, stage, production. So we get a pretty good confidence that we are pushing everything that we tested and qualified to production. So that minimizes the risk a lot. So I think, yeah, it definitely benefits our team in these areas.
Thank you, Hubert. That was great. Did anyone have any questions?
Thank you. So you said that Halyard is now kind of the recommended way of doing deployments. Does that include upgrades? Because we're actually facing this ourselves with doing an upgrade on Spinnaker, because we installed it like 2.5 years ago, right? So it's kind of before Halyard and all these newer tools. And we've been sort of tossing in, like, do we use Halyard to sort of basically bake new images and deploy that, or what? I mean, what's kind of the recommended alternatives these days?
So at risk of ruining Dan's talk, who's going to be coming straight up in a minute, he's going to talk about this. So there's going to be a talk about that in a minute, but I'll briefly answer your question. Is our direction is to use that tool, Halyard, to continue to bake an immutable image and create that template so we continue to have the self-healing.
Oh.
So what's cool about Halyard is it supports both models. If you've already deployed your instance with Halyard, you can hal config edit version and set the version to be the next version up, and then do a hal deploy apply. And as long as the original system is built with Halyard, it'll kind of take it and migrate it to the new version. There'll be downtime, of course. But as been said, our approach, we want to have an immutable infrastructure. So we don't want to ever change a running system. If there's a change, we want to build a new system, get it tested out, and then deploy it. And so in that case, we just go through the entire pipeline and bake it again. So the nice thing about Halyard is it supports both models, whether you want to upgrade something in place or you want to roll a new one.
Okay.
And I'll let Dan talk more about that in a moment.
Thank you.
Was there any other questions? Right, I'll pass this over to Anne.
Hi, I'm Anne. I'm another one of the engineers on the site reliability team. So I wanted to call 2 upcoming events to your attention. The first is the Grace Hopper celebration in Houston. And I realize it's mostly guys in here, but yes, guys can go to Grace Hopper too. It's a great conference. And we are actually, Emily Burns, who's right there in the audience. Hi, Emily. And I are, along with Jennifer Pedoff from Google, who wrote the SRE book, and Leslie Carr from Clover Health are presenting a panel on SRE. So this is actually the first time a panel is being presented on site reliability engineering. Part of what we're talking about is tools that make our life easier, and we're going to be talking about Spinnaker. And then Spinnaker Summit, everyone's going, right? Okay, I see like 3 people nodding, come on. Okay, who's going to go to Spinnaker Summit? Okay, I want to encourage all of you to look up Spinnaker Summit and consider going. I went last year, it was fabulous. It's an incredible wealth of technical information on Spinnaker. You should look into it. You should go. There's a huge number of excellent talks that we're evaluating, and I think there's probably some committee members for the summit as well in the room, so definitely go to that. Next, we have Dan Hart.
Okay, good evening. So I'm going to be talking about Halyard, as been said. Specifically, my talk's going to be about how I got stuck in a box, how I kind of got out of it, and there's a recipe box at the end with some useful recipes. Who am I? My name is Dan Hart. I don't use social media. Kind of have a LinkedIn. I don't really update it. I've been on the SRE team for 2.5 years. I grew up in Montana, but I came here as soon as I could. I love art, love hacking. Give me Scotch, make it really, really peaty. Outside of Pure, I'm involved with the Hack Your Lives group. I go to DEF CON every year. Hacking is a big thing to me, just making things work and do things. So the first question is, why migrate to Halyard? As been described, we have a Spinnakerized Spinnaker setup that we've been running for over a year, which has been working very well for us. He told you about how that's driven the rate of production outages down to, from configuration management and deployments, basically 0. So why touch something that's working great? Why change something that's working so well? And the answer is reverse engineering. The happy path is Halyard. When you want to do something like enable canaries, it's really easy to do in Halyard. It's a few commands, you can test it out, you can do it. And that's what all the documentation is written for. So let's say that you don't want to do that and you want to just do it manually. You have to reverse engineer the documentation, figure out which config files do I edit, what do I put in there. And as a result of that, our time to implementation rose. If you're astute, you will find at least 2 typos and 1 piece of pseudocode, which is just illogical and won't work if you're astute. And there's a typo here. So I tried baking it. I tried installing it through the guides that are online. And wow, it was just magical. Like if you follow the guides that Spinnaker publishes, you get up and running so fast. Even if you're not in GC, even if you're doing it, it's like you have yourself the this ticket, and you have like 2 story points, and you're thinking, there's no way this is going to take me this much time. I got this up and working in an hour. I'm just going to take the rest of the week off and have fun. But then I went to bake it because we Spinnakerize our Spinnaker, which means all this has to be automated. And I ran into a couple minor challenges, let's say. So what challenges did I run into? Well, the first one I kind of mentioned. The documentation is written assuming you're doing it in an interactive way because it's trying to get you up to speed. The documentation is great, but when you're trying to do that in a non-interactive way, in a way that's automated, that doesn't need a human sitting there confirming and entering data, you need to start thinking about, how do I do this? For example, you can't read this. I know it's way too small, but this says hal config version edit -- version. How do I get the version? I do a hal version list. How do I automate this? I always want to deploy the latest Spinnaker. I don't want to have to come in and change all this. Okay, that's fixable. There's non-happy interactive paths for some things. For example, Datadog, I'm assuming this will get fixed for eventually, but right now, you just cannot do it non-interactively. Anytime you try to pass anything to it, other than from they're using a Java library that's a secret prompt, it'll cord up. So that's okay. You have to figure out how to work around it. And I should mention, Lars is amazing. All the people in the Spinnaker community are amazing. You go to their Slack channel, you ask your question. You can usually talk to someone about it and figure out what I'm doing wrong. I mean, that's what it always is. But in this case, it wasn't actually what I was doing wrong. But there's a workaround. If you can't do it that way, you can, just drop it in KNetUp. So that's okay. These are just challenges that you can work through. The big roadblock I got to was hal deploy apply. Hal deploy apply, what's it do? This actually installs your configuration because you've made your configuration, it stored some stuff in an S3 bucket. Now it wants to go and install it, deploy it. It needs to grab a bunch of packages and install them. That's fundamentally the problem. I kept running into this issue where I already had dpackage locked, and now hal deploy apply is trying to install packages. And I slammed my head against this problem for over a week. I was stuck in a box. Not actually this box, but I love this box. This is a cool box. This is Schrodinger's box. If you don't know it, you should look it up. It's fun and it's cute and it has a long story. But the box I was actually stuck in this one. Some of you may have seen this as a challenge. You need to manage a way to connect all of these dots using only 4 lines. It's hard because you have an implicit belief. You have an implicit belief that you have to start a line at a dot and end a line at a dot. And if you have that implicit belief, you can't solve this problem. The way you get out of this problem is to get rid of that. You don't have to stop a line there. You can keep going over here, hit those 2 dots there, and go down. I like this example because it's literally a box of dots. And in order to solve it, you literally need to think about drawing a line outside the box. I call it the implicit belief blocks because you usually don't even notice that you're having this belief. What was my box? My box was our basically convention. We have a convention where we build a package, then we bake that package onto an AMI, and then we deploy that AMI. This pattern works great. This pattern works awesome. Problem is that it made me think that I had to do everything in the bake phase as part of a post-install script because that's how we'd always done it. And that's the problem, is post-install is part of the Debian package. While you're in the post-install, you have the package library locked. You cannot modify it. So then when you try to call a script, which is itself trying to install things, it locks. So I'm stuck in this box, not realizing I have an implicit belief, and I'm thinking, how the hell do I solve this? And I just came thinking I need to go deeper. Maybe there's a way that I can configure my Debian package to not need the lock. Hell, maybe, I told you I like to hack things. Maybe I can trick it. Maybe I can make it think that it's locked, but really write it anyway. Maybe I can write an alternate file and swap it. I tried some really, really crazy stuff because I just kept trying to go deeper. I just kept thinking, come on, I'm clever. I can figure this out. But I was trapped in my box. There is an escape to it. And I wish I could say I found this myself, but Lars helped me. Again, Lars is on the Google side of the Spinnaker team out in New York. And he's very generous with his time. When I've asked questions, he's always found time to get back to me. In this case, he was willing to let me present what I'm trying to do and give me feedback. And he very patiently let me present everything. And then he just goes and says, yeah, that's not going to work in a post install. I don't think you're actually going to be able to get that work. I'm like, oh, well, how do I Spinnakerize Spinnaker now with Halyard? And he said, well, have you looked at, and then he starts explaining this. And this is pretty awesome because when you think about it, it's not like the Debians magically appear on the AMI. Something has to install them. In Spinnaker's case, there's the script, and this comes from a script called install_packages.sh. I know you can't read this. The important thing here is it's a shell script. You don't need to read the details. But what it does is it goes through and starts installing packages. Okay, so what calls this? Well, looking around, there's some template files, JSON files. I know, again, you can't read this. The important thing here is that it's a JSON file, which is saying that for provisioning, use a script called install_packages.sh. So trace that back a bit farther. How do we tell it what template to use? And that was the magic. There's this template file name option in the bake configuration that lets you override that. Specify a different template. I can define that template. I can define a different install packages, which means I can do anything I want outside of the apt-get stage. I had literally escaped my box. And again, I know this had nothing to do with Schrodinger's equation. It's a completely different box, but Schrodinger's cat's awesome, and it's a box, so let's pretend and go with it. But as promised, there's a recipe box because I learned a lot, and I can probably share some of it. One of the first things is you always want to install the latest stable release of Spinnaker. How do you do that? Well, if you go back to that documentation, the way they say is do HAL version list, pick the version you want, and then deploy. There's also HAL version latest, which gives you the latest version. I could not get this to work, though, because I was looking at the usage, looking at the parameters. Okay, I don't need any of those. Go, and it would just fail. And I had to ask on the Spinnaker channel, and I saw the -q. You don't see this because it's not listed in the general parameters. It's actually a global parameter, one of these. And what it does, if you put -q, is it outputs less debug. In HAL version latest, there's actually no visible difference between using -q or not using -q. However, if you don't do -q, you get ANSI formatting. You basically get ANSI control codes, which makes it so you can't plug it into an automated method. And so the secret magic there is to use -q, which means you don't get the ANSI, which means this can just work as a one-liner. Another recipe is how to pass creds to the Git setup. This is pretty obvious, but I didn't know it at first, is you can literally just echo it and pipe it to HAL. This is the primary way of getting things into HAL in a non-interactive way. It doesn't work with a couple things like Datadog, but it's been very effective for other ways of not needing to use expect or some other kind of cheap hack in order to get it going. You can also cheat with subshells. And I've been trying, this is my first approach to get around that bake issue, is you probably see this a lot. If you are already in a package, you cannot access the package. What if you want to do something like in your pre-install, do an apt-get update, so that every time your Debian package is about to get installed, before it installs, you want to apt-get updates so that if it has any dependencies, it gets those in. You need a subshell. Basically what this is doing is, if this string isn't empty, apt-get grep done. In other words, it ran that in grep done because I'm clobbering the standard return code here and instead doing the grep done. That's giving me the right return code, then echo updated. How this actually works in a subshell, I don't know the precise magic on why this works because you can't always do it. You can do things like apt-get update. You can only go one subshell deep, and in some cases it doesn't work, but it is a very useful trick to doing some things like doing an apt-get update before you install. There's another thing you might want to do is bootstrap Halyard. I know you can't read this. The important takeaway here is that there is a directory structure of files. Now, if you deploy Halyard, in the user directory that you run Spinnaker as, there's a .hal directory which has configuration that when you run hal deploy apply, it sets it. Like let's say you want to use a different Redis server. You can plug that into a file under your .hal. In this case, it's under .hal, default, profiles, and then a file, service settings, dist Redis. And you can change which Redis server you use. Problem is that the .hal directory has a ton of these files, and you probably don't want to check all of them into Git. You probably only want a few of them. So my pattern for this is to run a hal deploy apply first, because before you do it, in your Spinnaker home directory or whatever user you're running Spinnaker as, you don't have anything. So if you copy anything to the .hal directory, you won't have the initial stuff that hal just creates out of the box. So first do a hal deploy apply to get the standard hal stuff. Rsync your own stuff on top of it, make sure permissions are correct. Then run hal deploy again. Basically, the first time you're running it, you're just creating your home directory .hal. Then you're populating that .hal with your own custom overrides. And then finally, you're running it again to actually deliver those onto the file system. And some of the commands are wonky. Just to give you an example, like I love this command because it's hal config version, edit version, and set hal version latest. It's a mouthful, but it means you're configuring hal. The portion of hal that you want to configure is the version. You want to edit it, and how you want to edit it is you want to set the version to be something new. And the version you want to set it to is the output of hal version latest -q. So you do maybe need to unpack them a bit. They're verbose, and they're kind of confusing, but they do definitely work. And that's the end of the recipe box. Do you have any questions?
Yeah, I'm also using Halyard to deploy Spinnaker. So one of the headache I'm having today is when you deploy the eager service to integrate your Jenkins node with Spinnaker, then every time when you need to add a Jenkins node or update the Jenkins node, you need to do the hal their update and redeploy the eager service. But that, and I use a Kubernetes to deploy that. That's a kind of headache to me because every time it's like running this, it takes time. Maybe just create a secret file in the Kubernetes and what's your experience?
So our solution to that, you notice from the pseudocode, is we have a way to get the secret for the Jenkins server. And so that way it's like we don't need to manually maintain, a different secret for every one. We have a mechanism to say, this is the secret for that server, go get it. However, it's absolutely true. Every time that we deploy a new Jenkins server, we need to add that to because we use immutable infrastructure, we need to add that and go update it. You might be able to do something similar, or I'm not necessarily recommending this, but for example, if all your Jenkins servers use the same password, then you could just get it in, or like you said, you could have your own, key file if you want to do it on an update. In our experience, I don't have a good answer for you because for us, we have chosen just every time we need a new Jenkins server, we'll go ahead and deploy. That's because our strategy is any change, no matter how small, you want to do it redeploy and reimmutable. I'm sorry, if you, yeah, please.
So I got a question about your question. Are you having your endpoint for your Jenkins change every time you replace your Jenkins? Is that what you're saying? Or are you adding completely new Jenkins servers that have never been used before?
Both, actually both.
What?
Okay.
So in my case is I'm supporting not like a small group. It's like an entire company, and there are many groups, and they have different Jenkins servers. And some of the Jenkins servers, they are also running in Kubernetes, and whenever they probably redeploy and the endpoints change as well. So, and my headache is there's a lot of Jenkins nodes need to change very frequently. I already use one common service account and the general password, so I don't need to ask the password.
So it's really the endpoint
every
like
time. But even add or remove Jenkins, like I need to update the Halyard configuration file and redeploy eager services and then wait for that down, up, resize things. So
Could you possibly do like DNS alias for the endpoints and just manage it with DNS, perhaps? I'm just thinking out of the box. So that way you don't have to change the config file for the endpoint.
okay.
If it's the same Jenkins server for the same work.
Yeah, I think that's that's a one problem we can resolve. But if I need to add a complete new Jenkins node, so
Yeah, for that I don't see any other way but to update the config.
okay.
I do recall in the sync up group, was anyone here in the sync up group the other day for Kubernetes? I do recall that there was discussion about potentially a way to maybe do that in the UI at one point, but I'm not sure where that's at.
Yeah, I remember that. Specifically, it was about being able to, as you add new clusters, be able to add those. And I think they were saying they want to do the same thing with Jenkins so that you could do that. So I think a feature like that might be coming to Spinnaker. I'm like Vincent, I'm not necessarily sure. But I think that's a common pain point that a lot of people have, is that what's one of the most common things you're going to need to reconfigure Spinnaker to do? It's to add new Jenkins servers or a new endpoint. To the endpoint thing, I would just, from an SRE point of view, I always like the idea of putting some level, like a DNS or something, in front of endpoints, because sometimes you might want to have endpoint A, endpoint B, and maybe you have a really big version change, right? And you want these running, and you want to be able to roll back. And Spinnaker really helps you do that. You can, of course, do different server groups inside of the same load balancer, but for sometimes you may want to actually have something deployed completely separate. And when you have like an alias above it or anything else, you can kind of flip back and forth at the network level. So it just gives you extra flexibility. There is specifically a Spinnaker Kubernetes Meetup group that runs, I think, minutes every week or every 2 weeks. But we talk about a lot of interesting things because Kubernetes is so new, and Spinnaker is still maturing and getting better all the time. So there's a lot of things there. How often do you add new Jenkins servers?
Sometimes a week, once a week.
Okay.
And sometimes a lot of, several, requests in a week. Yeah.
Right.
Yeah, but sometimes it's like maybe a month or so. Yeah.
Do you use Halyard or?
Yeah, I'm using
Okay.
Halyard.
So luckily, if you use Halyard, you can add a Jenkins server, not too much, but you need to restart.
Yeah. Yeah, and sometimes when people, because for example, some of the groups, when they request the Jenkins node add to the Spinnaker, and then probably they just want to try it. And after trial, they already tear down their Jenkins node, but they didn't inform me. And then I had to monitor the eager log and say, oh, this is a bad node already.
Right.
Yeah, and those are the kinds of the headache to maintain
Right.
the Spinnaker. Yeah. So
Yeah. No, that's interesting. I don't know of a easy solution offhand for that, but that's super interesting. That it'd be interesting to see if you are active on the Slack channel. There is I want to say it's Spinnaker something.slacks.
Yeah. I know.
Yeah, and in the dev or general channel, I bet someone would either say we're working on something like that, or give you advice that I don't know. Because like I said, our strategy is we've chosen the immutable path, so we're okay with running, and then we're okay with rebuilding and launching a new Spinnaker a couple times a week. Since we have the pipeline for it, it's basically a get change and a get push, and then we wait. Any other questions? Yeah. Thank you.
How do your users manage the pipeline configuration?
Our users currently manage the pipeline configuration by the Spinnaker UI and modifying it. I think some teams, when they need to do multiple pipelines, will go in, kind of export, copy the JSON one and import it. We've had a few teams look at kind of pipelines as code and working on things like that. There's new support in Spinnaker that lets you do this, that lets you actually just upload a pipeline and manage it. It's something that we have on the radar, but right now, the best path for us is to continue to just do it through the UI. That does create the pain point of when you have a new project, you're kind of going through and clicking through the same UI. That's why I alluded to. Sometimes, we'll take the JSON from a pre-existing pipeline, paste it in to kind of get something there, and then we go tweak it. Personally, I would love to get to where we could, have these pipelines as code just to accelerate it. But that's kind of something that we have on the back burner that we want to do, but it's not urgent. But yeah, right now we're primarily doing it through the UI.
So do you process to back up Spinnaker configuration like the pipelines periodically?
Sure. We use the Elasticache Redis and those backups for our pipelines. And so we're not just storing the Redis locally on it. That also means that when we roll a new Spinnaker version, we maintain pipeline history. Beyond that, we don't do a huge amount of backup of that beyond just what Amazon gives us. If we absolutely have to lose pipeline history, it's not the end of the world. The important thing is the pipeline configuration itself, which is in S3, which you can do things like enable versioning on the S3 bucket. And if you really wanted to, you could back it up. But Amazon's durability for S3 is pretty high, and we've been okay with that for the database. Cool. Any other questions? Awesome. Well, thanks again for listening. Sergey.
Hi everyone. Thanks, Dan. So I'm Sergey. This is a lightning talk, by the way, which means it's faster. I'm Sergey Liproselsky. I'm also on the Cloud SRE team that Ben, Dan, Tony, and Anna are on. And I'll be talking about a Spinnaker CLI tool we developed called Shaman. So one might ask, why do we need the Spinnaker CLI tool? One reason for that is to do some custom management and reporting that may not necessarily be built into the Spinnaker UI or some other tools, but is accessible via the API. And another reason is to replace some of the existing custom AWS scripts that we have. But without writing scripts against AWS specifically, because what if we want to use a different cloud provider? We don't want to have to write a different script for Azure, a different script for Google, and Spinnaker kind of helps with that because it gives us the Spinnaker API is like a unified interface. An instance in Spinnaker is an instance in Spinnaker. It doesn't matter which cloud provider it's deployed to, for example. And another nice thing is Spinnaker also caches some information, so we don't need to make a ton of API calls against our AWS environments, for example. If we want to get like a list of all the deployed instances, we can just ask Spinnaker and lower our damage onto that we cause to the API limits. So we're always kind of mindful of hitting these API limits in AWS. So more specifically, the requirements we had for Shaman were we want to be able to describe basically each Spinnaker application and its clusters, server groups, instances, other info, all at one glance rather than have to click through the UI. Like if you wanted to get the IP addresses of some applications, instances in dev, instead of clicking a bunch of times, you enter one command in your CLI. Also makes it so you can use like grep if you want to find something particular. We also wanted to be able to This is something Ben talked about, the report which machine images are used by which Spinnaker applications. This way we can tell if certain applications are behind on some important security patch. We can see, oh, this application is using an old image, so it's not patched for Spectre. Contact that team right away and include the security team. And another requirement was to identify instances in disabled server groups in Spinnaker. So basically instances that are not being pointed to by a load balancer that are very likely just sitting there because somebody forgot to destroy them after a bad deployment. They're probably not getting any traffic. So we can identify some clusters that are not used and that way save some costs. So the setup that Shaman requires is just Python 2 or 3 is compatible with both, needs OpenSSL greater than or equal to 1.02 as I found out, and basically gets its configuration to talk to Spinnaker from a .spinnaker directory in your home directory. And we authenticate via X509 certificate and key when talking to the Spinnaker API. Okay, so now we can go through some of the functionality. There we go. So one of the main functionalities of Spinnaker or of Shaman is called Divine. That kind of gives you, basically describes every single application in Spinnaker, every single cluster in that application, every single server group in every cluster, every instance of every application. And you can also do it like per stack if you want to just see the ones for dev, staging, or prod, or whatever stacks you might have. And also you can specify a particular application if you just want to see info about one, or you can list them all if you don't specify an application. And then one thing we also found is that if you already have a bunch of existing autoscaling groups in your AWS environment, when you deploy Spinnaker, those will start showing up in there, but by default, I filter them out. But if you use that show all flag here, it'll also show things that may not necessarily be Spinnaker applications. And then we got the audit base AMIs command, which I mentioned will report applications and what machine images they're using. Basic. And this is the one that reports audit instances, the one that reports any instances that are disabled, and we can probably terminate it to save some money. And I'm going to attempt a live demo to actually show you what it's like when you run it. All right, so this is actually running against our Spinnaker API. So for example, Divine will list every application in this kind of format where you might have some general application info like cloud provider, application name, description, email address for who to contact for this application. And then we have clusters. For every cluster, we have server groups, and in each server groups we have instances, and we can see their IP, when they were launched, what kind of instance type it is, and then the base machine image used in these server groups. And by looking at these base machine images, we can actually know at which patch level is this particular server group. Similarly, we could do a particular application. Do something. Oh, there's dash. There you go. So this is written in Python. And it even auto-completes. So it actually queries Spinnaker API to suggest you a list of applications. You can hit tab once you're like halfway through typing it. What's running in dev, what's running in prod, what's running in stage. Could do a particular stack if you want, like what do we have in prod right now? All right. So that's already pretty useful kind of for getting an overview of what do we have running. So then there are the two audit capabilities that I talked about. One is the base AMIs. This might take a while because it basically has to ask all the server groups of every application, which base AMI is it? And this is all just talking to the Spinnaker API. I'd actually do another tab for the other audit commands to parallelize this demo. All about efficiency and stuff. Tabs. It will end soon.
We had a lot of debate about this, but I said no more slideware.
No more slideware?
No more slideware.
Trying to figure out how to share another tab in the same terminal window.
So while we're waiting, where's the bottleneck?
Oh, why is it taking a while? So that's just, I guess it's the speed at which the Spinnaker API responds to the requests made by the script.
I think it's Zoom. You click your Zoom and read it. We had this issue occasionally where the presentation software pops up. It makes your demo look fantastic.
It does say sharing is paused. All right, sorry. Ah, there we go. All right, so that's the output of the instance auditing command. And so you can see it looks like we have a bunch of stuff running that's in disabled server groups, which means there's no traffic going to it through ELBs. So what I'll do after this presentation is contact people at this email address and ask them if we can shut down these servers. And actually doing this 2 days ago saved us about $1,150 a month. And here's the, it doesn't switch that.
Just run the audit again. It's going to be quick.
Yeah, I have it in another terminal window, and it doesn't switch to it. Oh, here we go. So this is the output of the audit for the machine images. So here we can see for this machine image, such applications are using it. For this machine image, these applications are using it. And then we have an internal kind of tracking of these machine images where we keep track of what features go into which ones have which security updates. So if we wanted to see what's not updated to this latest image, run this command, and we'll see, okay, these applications are using an old one, then maybe they're vulnerable to some meltdown or Spectre vulnerability. All right, so those are the 3 Shaman commands we've implemented. Can you start the... Yeah, so this is kind of a start. We met our initial requirements, but we definitely want to do more. There's more things we want to report, and we also want to add some management functionality to Shaman as well. See, right now it's mostly just listing stuff, describing stuff. We want to be able to do some management. Maybe we'll call it Shaman Voodoo, something. So yeah, next step for this project, query the Spinnaker API for available stacks. Right now I just have it hard-coded in the script, like dev staging and stuff like that. Add more output formats, something maybe more script-friendly like JSON and CSV. You want to put it in Excel. Provide an option to just give IPs. If you just want to get an IP to SSH to look at some problem. Get more people to use it internally to find any bugs. And hopefully open source, because right now you guys can't use Shaman. All right, any questions? Opinions, concerns? Go ahead.
Where did the requirements come from for the listing?
So like I was saying, we're replacing some existing tooling. So some of it came from that, like being able to just list all the instances in a particular environment. Some of it came from that. Auditing machine images, that kind of comes from security. They want to know about that stuff, how up to date an application is. And then the one for auditing disabled instances was just somebody's idea at a meeting when we were discussing costs. And that's kind of how these options get added.
That's awesome. I hear a lot like people want a Spinnaker CLI.
Cool. Yeah, we're working on open sourcing it hopefully soon, and then maybe other people can add functionality as well.
So when it comes to auditing AMIs, how do you determine which ones you want to pay attention to, or which ones you want to declare as having vulnerabilities? Do you have separately a manifest of images which have known problems?
We do. So we have a whole process for building our own kind of base images that then all the applications use, and we kind of keep track of in a different place. For each image, what vulnerabilities does it resolve? What is it vulnerable to? What packages are on it? Things like that. Any major changes. So we keep note of that for every kind of base release that we make to the development teams to use.
Okay, but then they bake their own images from the base images plus their package. So are
Right.
you tracking that sort of that history, that ancestry?
Ben has an idea.
Yeah, absolutely. So we use the ability to, I can't think of the right term for it. Yeah, work, I think it's like declaring a variable in the tags that we apply to the running instance that references the base AMI that the application was built from through the pipeline. So when we inject the base AMI that then the application application package is built on, we inject that source base AMI, which is the one with all the patches in it, into a tag, and then we're querying that tag for that output. And so we have that source. Did that make sense?
Yeah. Basically, the developer or the sort of the product images essentially a tag with what's their ancestry,
Yeah,
and then you can follow the chain.
Yeah, it's the
that makes
ancestor
sense.
AMI. Yeah, that's correct.
Utilizing that tag that Ben was talking about before, where we tag every basically with who's its ancestor. All right, one more question.
So it looks like a lot of this is used in real time. You want to see what state the whole system is in, but what thought have you put into collecting this data and putting it into a database so you can maybe look back historically about where things were, like perhaps to go backtrack what events occurred back in time?
Yeah, that's a cool idea. We haven't really done that yet, but yeah, we could totally have, I guess, the tool report this to, or let's just save this in some database and view it over time, how it changes. That's a cool idea. Maybe in the next version.
Yeah. Okay.
Okay. Thank you. I think I took enough time.
Great talks with Ben, Dan, and Zach. So your OpsMX. I'm a CTO, Mike Gopinath Rebala, and we provide services for Spinnaker. So we support in onboarding as well as ongoing operations. We also have our own product for canary analysis or continuous verification. We add, so Kinetalk comes with Spinnaker, open source, add log analysis to that, so product. We had heard great talks through Bren today on Spinnaker importance in the DevOps. Particularly, he touched on or explained in detail what that immutable server architecture is, how well it does in operations, and most importantly, how the developers and operations come together to give a much better knowledge of what is going on in operations, deployment, production. So one of the things we found is with the Kubernetes being new, and there are new systems that are coming in that have the Kubernetes as the base operating system, like the OpenShift or DCOS, which have much more restricted environments in running the containers. Spinnaker itself used to be require root as a user running the containers, not anymore, but it still has few issues on running in these restricted environments. So today we'll just discuss what those issues are and how do you build the custom containers that get around those restrictions? How do you deploy them? Actually, for building custom containers, you have a couple of different reasons. We'll just go through. How many of you are using Kubernetes? Good number. So one of the things that OpenShift environment or DCOS does to Kubernetes is adds additional layers on top, particularly for security. So the one thing that they do is the containers, they don't run as a known user. They run as anonymous user. In those environments, in some of these containers of Spinnaker itself, they don't function, particularly front. So one way to do it is take those containers, inject these workarounds that you can do to allow the anonymous user to run, build those containers. And process. The other issue is in enterprises, sometimes they don't allow these to be deployed directly from public repositories. Now, you want to pull those things, put them in your local repositories, have them access to local repositories to deploy using Halyard. So those are the things that we want to take care of. You don't necessarily want to install nightly builds. You want to take a released version of the latest. Now, if you want to pull those containers in, get the right versions for that, of all the containers for that version of the release, there is a bill of materials file. You can get that through HAL version BOM, same as the URL there. That includes all the components of Spinnaker, the versions, manifests that you can use to deploy. So if you want to take that, have it in your local repository, you simply have to parse this BOM file, your local repo, and that's ready for your deployment. Now, one of the reasons to build your custom containers is build in your certificate chain. Usually, say you're connecting to your LDAP server. Enterprises, they have their own certificate authority issues. Here in this case, I'm showing just one certificate they're putting in, but it is possible that you have a certificate chain. Essentially, you start from the release version of the gate. I think everyone is familiar with Docker file format. The Docker file is essentially manifest you specified to build the container. Here, what we are saying is you start with the released version of the gate. To that, add your certificate, and then run the key tool to trust that certificate. After this, you just have to say Docker build. It will build you the container of gate, this version with your certificate. And that you simply push it to your local. No, for Front 50, one of the special issues is that it expects the user to be root or Spinnaker user for it to work, particularly connecting to S3. For S3, it's the same thing with many of them. You can either inject those credentials as environment variables, or you can have the anonymous user point to those credentials. So if you want to change the environment variables, then you actually have to change the replica set that Spinnaker Halyard is deploying for those frameworks. It's slightly more complex. So the easiest thing is to change the Docker file, update the user, the anonymous user, and link that credentials to that user. So one of the things that I'm not presenting here is how do you take that anonymous user, and there is a small trick for these environments like the DCOS, OpenShift, where user ID, generally the way they do it is they take 1 million or higher user ID and that user ID. But they also have permissions for the group to basically use that trick and say permissions to the files for the root group. Provide this link there that allows Front 50 to work. The same issue exists with the Halyard also, and also deck. Do the same kind of tricks. Build the deck, build the Halyard, push it in to your local store. One other way to do it is, in some enterprises that we work with, they also had this problem that for the cluster, they won't allow any internet access. In that case, when you are deploying from public, you won't even be able to get the bill of materials file. But Halyard requires, by default, requires to go to that URLs to get the bill of materials first, get all the manifests for individual. But in those cases where you don't have access to the internet, then you can pull in the complete manifest from the GCR.io, including for all the subcomponents like Cloud Driver, Deck, Gate, Door, all of them. And then you can create the same structure. And you can configure the Halyard to point to that structure. That's done. All you have to do is change the artifact ID. So in Spinnaker, there are two Halyard. There are two structures Dan was mentioning. There is a profiles and there is a server settings. Profiles is additional configuration that you would provide, something like you're configuring new accounts with the cloud provider, new accounts with Jenkins. Those will all go under the files type. And the server settings, if you're changing the core settings, like artifact IDs, they go under servers. So all you need to do is simply change the artifact IDs at 150 that you build, push your, give it a version. So you specify that artifact ID for the containers, and then do a HAL deploy. Usually the HAL deploy apply to Kubernetes environment, it does a blue-green deploy. It automatically does that. It waits until the new cluster comes up. After completely comes up, then it scales down the previous version of the cluster. And it's ready. Here, when you do HAL deploy apply, it will deploy all the components. You only want to deploy one specific service, like the front 50, you can pass in an option, say, front 50, that will only deploy. Basically, you want to custom containers based on the base builds of the release versions, and then apply them in Halyard. You can always build the containers from the source. Docker files, one is a Docker file slim and Docker files. Diagnosed. Slim is the smaller version, built under 100 to 300. Any questions?
So now we're just going to open this up for general questions and answers. We really don't have a format for this. If you guys have questions about what's been presented tonight, or if you have questions about your own environment that you'd like to share with this larger group, then we're all ears. And if you don't.
Yeah, I actually have two questions. I brought that question to this meetup. So
okay.
Yeah, one is since I guess we are talking about the running Spinnaker on Kubernetes, right? And and by the if using Halyard to deploy the Spinnaker to Kubernetes, by default all the pod size is just one. There's one instance. So.
Yeah, you can configure the number of pods to deploy. You can configure the size of.
But can we just because there are multiple services within Spinnaker, so there are like Deck, Eager, Gate, Orca, etc., etc.
Right.
So what's the experience if, for example, the usage for Spinnaker is really high? Shall we just change the number and that it just magically
right.
work and no?
Right. You can change the number. You can increase the size allocated for each container. For example, by default, the clusters admin sets up saying each pod comes up with 2 GB and 1 CPU. Okay. You could change that and say, I request 4 GB, 2 CPU. Okay. So usually the cloud driver is the one that takes long.
Okay.
And the steady state, those are the ones that you would.
And also for Redis, because by default, the Redis deployment that's just run in the memory. And if that container is lost, for example, the node is down, the Redis unfortunately is there, and then we lose all the pipeline running histories. So, and what do you have any experience or solutions if we want to persist the Redis so that we can still survive from the disaster while we still keep all the histories?
Yeah, so Redis, if you're running in Amazon Elastic Caches, have them auto-replicated. Pod goes down, have the Redis running in Amazon that you're connected. Take care of replication of. If you're running the Redis in your own environment, you don't have to have the Halyard manage that. You deploy it outside the Halyard. And to that instance, you can set up. You can have the master-slave configuration for those Redis. The master goes down, you still have the slave. Data for the Redis also. Usually, it does persist on the disk while it's running. Two formats. One is the compact format. One is all the transactions that are saved. Can replicate.
Similarly, I need like a register cluster, so to separate setup, then custom
usually
that
that's
configuration that will.
You will only lose the execution history of pipelines, but the pipeline configurations and other things will stay.
Okay.
Two different databases.
Yeah. So one is the persistent volume that the front 50 persist the pipeline, the applications, and the other is the I believe that is the message queue in the Redis, and that's the running histories and also some runtime message queues pipe there. So, all right. Yeah. Thank you.
Any other questions?
What about auto scaling support? What about auto scaling support? So
auto scaling support?
Yeah, so rather than manually going in and configuring when a bigger instances or more instances and so forth, just have
you can configure.
Okay, so it's compatible with that. Okay.
Well, you guys look pretty glazed over. Hopefully you guys found this informational. If there are no more questions, we're going to invite folks down to St. Stephen's Green. It's about 4 blocks down that way on Castro Street, if you guys are feeling social. Again, I really want to thank our speakers tonight, Gopinath, Ben, Ann, Dan, Sergey. Oh, I know my team. And a special thanks to Balaji for helping get this set up. Again, I understand that was kind of difficult to get into this building and find parking on Castro Street, so we've got a few lessons learned for our next meetup, but we're looking forward to having you guys here again at some point in the future. So thanks for attending, and we'll escort you to the elevator lobby. There's an opportunity to use the restrooms if you want to do that. And we'll get you guys down here. I'll get you guys down to the first floor in a short order. So again, we really appreciate it, guys. Thank you very much.
Thank you, Tony.